All right, so we actually mainly have two resampling techniques. There are other resampling techniques that you can actually find, but mainly there are two some resampling techniques that you can actually use when dealing with data imbalance. Okay, the first one over here that we are going to talk about is what is called upsampling or oversampling. Right, so sometimes you'll be seeing upsampling and sometimes you'll be seeing oversampling. They all mean the same thing. Okay, and then you also see downsampling or undersampling. All right, so sometimes you see downsampling, sometimes you see undersampling. They are all the same thing, right? They are all the same thing. What we can actually do is that to pick them one by one and then talk about them. So we will first talk about the upsampling or the oversampling, right? So we're going to see that one over here. All right, so let's see how we do upsampling or oversampling, what this actually mean. All right. Okay, so let's see this diagram, which will make us understand this oversampling or upsampling better. Right. So when we talk about upsampling, we are talking about a situation where, as we said, we have data imbalance. Right. One of the data points is less, right, whilst the other data point is much, right, or is quite huge over there. Now, what we want to do is that we want to upsample, or we want to make the small data set match the big one. Right, so in this case we want to make the fraud cases match the not fraud cases, right? Because the fraud cases, if we go up here and see what we have over there, let's go a little bit up, right? So we want to make sure that this amount matches this amount, or if we better still, we can see it here. We want to make sure that we make this 87, right? We make this 87 match this to 23,235, right? So 23,235. We want to make the 87 match the 23,235 over here. Okay, that's the upsampling. We are going to make this one go up to match this one, right? We're going to upsample this one to match this one. So let's see how that one is actually done, right? Let's see how it's done. So as you can see in the diagram, we are making the orange match the blue, right? So we can say that the blue over here, right? So in our case, the blue over here will be 0 and then this one will be 1. Okay, so we want them to match. So over here you can see that now the 1 will match the 0, right? The 1 will match the 0. So let's actually go and see it's over here, right? Just forget about the labels that you have over here. Just explaining that the other label should match the other label. Okay, the other label should match the other label over here. Now let's see how this thing works. Okay, so now over here, what I'm going to do is that I'm going to use the resample method, right? I'm going to use the resample method over here. So for that, I will need to import this resample package, right? Which is part of the etils in sklearn, right? So I just do from sklearn.etils import resample for me. Then what I'm going to do over here is that I'm going to select the not fraud one, that is the ones that are equal to 0, right? The class that is equal to 0, and then I store it in a variable called not fraud. Then the class which is equal to 1, which is the fraudulent case, I store it in a variable called fraud. Okay, so that's how I'm separating the class data set. All right, then after that, what I'm going to do is that I'm going to use the resample package that method that I imported over here, right? And when I use that, I'm going to pass in the fraud, right? Because the fraud is the one that I wanted to match the not fraud cases. Okay, I want the fraud cases to match the not fraud cases. So what I'm going to do is that I'm going to pick a point in the fraud cases, right? And then when I pick it, I put it back. I pick it, I create a data point out of it, and then I put it back. So it's more like I'm duplicating the values in there, okay? But I'm going to do it with replacement, okay? That's why I'm using replace equals true, right? So if I pick any data points from the small data points, I put it back before I pick another one to duplicate, okay? So that's why I have replace equals true over here. So I pick one from it, from the resample, or from the fraud cases, then I put it back before I pick another one. So that's why I'm saying that replace equals true. Then the length that I wanted to match is the not fraud, right? I wanted to match the not fraud case. So I want the ones here to match with this one, okay? So that's why I want the one to match with the zeros, right? So that's what I'm doing here. So I just use n samples because the length of this not sample. So the length of it is actually 23,235. So I want this one, which is 87, to match the 223 235, right? So because this one is actually, the fraud cases is only 87 in there, right? So I want this 87. I'm going to pick one of the 87, right, and then duplicate it. Then I'll put it back, right? Then I'll put it back. Then I pick another one, duplicate it. I put it back. Pick another one, duplicate it. I put it back. Okay, and then until I have amount which is equivalent to this not fraud, right? Because this not fraud is actually 23,235, right? So until this amount is equivalent to this amount before I stop, and I'm going to do this randomly, right? I'm going to do this randomly. That's why I'm setting random state equals 27. I mean, this 27 value could be anything, right? It could be say 1, it could be say 10, it could be whatever you want, right? Just that you just have to state you just have to state that random state equals something. So that's how I'm doing it randomly for the first time. It will do it the same way each time I run the code. Okay, each time I run the code. All right, so let me just comment these things out. All right, so what I'm going to do is that after I've done these things, right, I'm going to store everything in a variable called fraud data app sampled, right? I'm just going to store it in a variable called that, right, just to show that I have sampled the fraud data. Okay, then I put them together, right? That is the not fraud and then the new app sampled fraud that I've done over here, right? I put them together using the concat function over here, right? So my new data set is now going to be called app sampled, right? Instead of df, right? Originally we have our data set called df, right? So we've been using df all over, right? We've been using df right from the beginning that we loaded our data set, right? So now we have a new data set called app sampled. Okay, we have a new data set called app sampled, and that's what we actually going to see how we're able to actually do that. So now let's see the classes again. Let's check the value count again, right? Earlier on we used the same value count up here when we're using our original data set, which is df, right? We used the same value count, right? We use the same value count over here. So df class then dot value count. So in this case we are not going to use df again. We're going to use app sampled because that's our new data set. So app sampled class dot value count. That's what we are going to do down there. Okay, so let's go and then see the output of that. Okay, so now if we see the output over here, so now you see that 0 is now 23,235 and 1 is also 23,235. So you can see that we've been able to upsample the 0 to match the 1. Okay, unlike what we were having earlier on where we're having 23,235 for 0, right? We're having this for 0 and then 87 for 1. Now we've been able to match them using that resample technique. We've been able to match these data points. So now our model will not actually memorize anything there because now we have data points which are equivalent there. We have a balanced data set. Okay, now we don't have imbalanced data set again. Okay, we can also use this random oversampler, right? We can also use that one to achieve the same thing that we have done over here, right? So in this case I used the resample, right? We can also use the random oversampler to do the same thing that I've done. Okay, so let me show you that one as well, right? Let me show you that one as well. So what you need to install over here before you move ahead is to install this imbalance lane, right? So if you since I have it already, right, it's just showing me requirement already satisfied. But if you are doing it for the first time or you don't have it, it's actually going to install it for you. So you just run this command, right? Then what I'm going to do over here is that I'm going to use that random oversampler over here. So I'm going to import this counter, which I'm going to use later on to count the new data set that we are going to create. Okay, so we'll use it later on. Now I'm using the random oversampler over here, which is part of the oversampling package in the Imbalance. Okay, and so I'm using from Imbalance dot oversampling import random oversampler. So you actually need this Imbalance over here. That's why I say that you have to install this imbalance land over here. Okay, now after that I have that package over here. After that I have my package over here, I need to just initialize it over here, right? So just the same concept, initialize it to a new variable, right? So I just create, name it random over. You can just name it anything that you want, maybe RO or something like that. Okay, then random state equals 50, since we're going to generate random variables and we want the same random variables over and over again. Now after that is done, I'm going to use the rand over here to actually make it learn on the x and then the y, right? So my x and then the y here are the x and y that we created earlier on, right? So if we go all the way up, right, we have our x and y here, right? When we're creating the dummy classifier, we created our x and y. So it's the same x and y data points that I'm using now over here, right? Here, okay. So I use random over dot fit sample, right? Fit on this sample data points that I have. Now I'm going to count the original data points that I have in the y, and then the new one that I've been able to create, right? Remember that when I create this, right? When I create this, the new y is going to be stored in what is called YRAC, just y receipt, or also whatever you want to name it. I could have just named it as maybe y, or maybe new y. I could have just done that, right? You just a name that you want, you can just do, right? Or x new, whatever you want. I could have also done it in this way. Okay, now I'm now going to print the length and see if they match, right? So I'm going to you could have also printed the x and then the x rest over here, right? I'm just printing the y and then the y rest. So you can also run that one and check for the x and then the x rest as well. Okay, now if you see the output over here, right, this is what we have. You can see that originally we're having 0 to be this, which is 23, 23 to 35, and then the ones to be 87, just like we saw earlier on. Now we can see that the zeros are 23 to 35, just like originally, but the ones have been upsampled to also become 23 to 35. Okay, so you can also use the random oversampler to achieve the same thing that we did over here using the resample, right? So these are just two techniques that you can actually two methods that you can use to achieve the same thing. Okay, after that one is done, now we have a balanced data. So now let's use this balanced data to build the same logistic regression that we did earlier on, that was giving us a poor performance, right? When we checked, the accuracy was doing good, 99 point something, 0.6, right? But when we changed the performance metrics to confusion metrics and F1 score and recall, we saw that our model wasn't actually performing good. So now that we have a balanced data, now let's see how logistic regression is going to do, right? Let's see how it's going to do over here. Okay, so the same thing that we've done earlier on, just import logistic regression and then use your y and then the x. So remember that we've created a new data set called upsampled, right? Which is what we've done using the resample method. We've created a new data set called upsample. Okay, so that's what I'm going to use. I'm not going to use df, which is the original data set which is having balanced data. I'm using the one which is not having the I'm not using the original DF, which is having imbalanced class in there. I'm going to use the upsample, which is having the balanced class. Okay, so my y is now the upsample.class, and then my x, I just drop the y out of it, or I just drop the class out of it, and then the rest is going to give me the x trade. That's what I'm going to use to build the new logistic regression. Okay, so over here I just need to initialize the logistic regression, right, just like we did earlier on. Then I use it to fit, right? So I'm just doing the two things on the same line. I could have maybe done it here. Maybe I could have written here model equals this to initialize this. Then I use model.fit to make it learn. Okay, so I can also do it this way. It's just different ways of doing it, but it's achieving the same thing. Then I make the prediction, right? Now let's check again the performance and how it is doing. So we are going to use the accuracy again and see. Earlier on we're having 99.6, so let's see if this one is also doing good. Now you see that even it has reduced, to 98, right? We're having 99.6, now we have 98, right? Now you can see that the memorization has reduced, right? It's not memorizing as it was doing earlier on, giving us 99.9%, 0.6%, but now you can see that it has reduced, right? Now if we check the recall again, right? If we check the recall again, let's see if that's improved. Now you can see recall is now 1. right? Recall is now 1, which means that the model is able to recall better as compared to the one that we're dealing with earlier on, right? When we have the imbalance data, right? When we check the recall for logistic, let's go a little bit up. Okay, so let's come here. Yeah, the recall over here was somewhere around 69, but I mean 6.9 if you want to think it, I mean in terms of 1, right? But now you can see that we have a 1 here, which is actually doing better because we want to approach 1, and this one is already at 1, right? You see that now recall is now better. Okay, now that this one is actually done, let's actually see the confusion matrix as well, right? So we are not just using the recall and the accuracy, we're also going to use the confusion matrix. So we are testing different performance metrics to see if everything is going on well. Now you can see over here there's an improvement over here, right? You can see over here there's an improvement. Okay, although there's still some mistakes in here, but now you can see that our model is also able to remember the small class, right? It's now able to remember the small class, right? This is a huge data point, so obviously it's going to make that kind of a mistake, but this is very small, so it's supposed to be able to remember this as much as possible, which our model is now doing. Okay, and that's basically what we want, right? That's basically what we want. We don't want to even make any mistake when it comes to fraudulent cases. We don't even want to make mistakes. If the data, if the transaction is normal transaction and our model is predicting that it's fraudulent, that's fine. But if our model, it's not that fine, but it doesn't cost us much. It doesn't cost us much. But if our model is if the transaction is fraudulent and our model predicts it as not fraudulent, then that's actually going to cost us. So we want to prevent this part as much as possible, which our model is now doing. Okay, all right. So with downsampling or undersampling, what we do is that we want to reduce the majority class to match the minority class. Okay, so we have a class which having less data points, then we have another class which having more data points. So we want to reduce the one that is having more data points to match the one that is not having much of the data points. Okay, so in our case we have 23, right? We have 23 to 235, right? We have 23 to 35, so we want to reduce this one, and then we have 87, right? And then we also have 87. Okay, so we want to reduce this 23 to 37 to match the length of this 87, right? So this one should become 87, so that we have 87, right? We have two 87s, right? 87 and then another 87 in both of them. Okay, so that's what is happening here. We are reducing this one so that it will match them, so that both of them will have the same height or the same data points in there. Okay, now that we know what undersampling or downsampling means, now let's go and see how it is done. Right, let's go and see how it is really done. So not much difference here, just that we just change the way that we're doing it. So this code is just the same thing that we use for when we're dealing with upsampling, right? If you see it over here, just the same code that we are using. This is for the upsampling that we just did. So instead of doing fraud here, we are going to interchange them. We put fraud over here, right? So over here is going to be fraud, and then here is going to be not fraud, right? So that's the only thing that is going to change down there. Okay, so let's go and then see how that one is, right? That's the only thing that is going to change. Right, so as I said, you can see over here that we have this one, not fraud, right? And then we have the fraud here. So now we're going to make the length of the not fraud match the length of the fraud. Okay, the same code, the same explanation, right? We have the zeros to be not fraud, we have the ones to be fraud, and then we use the resample over here. We pick and replace, and then the length is going to be this, and then we do it randomly. So this is just the same thing, right? We're just going to make sure that the more ones becomes the same thing as the less ones, and then we put them together. We have our new data set called downsampling. All right, so the first one was called called upsampled. Now this one that we've downsampled is called downsampled. So we have three data sets actually. We have DF, which is our original data set, then we have the upsampled and then the downsampled. All right, so now let's see this one. Let's actually check the class again and see how the distribution is. Okay. All right, so now you can see that now instead of 23 to 37 for the one, now you can see that it's also 87, and the 0 is also 87. So we're able to downsample it to match these data points. All right, now after we've done that, let's actually see the result. And let's actually use this downsampled data set that we've created, right, on the same logistic regression and see how things go. So over here, the same code, right, we're just going to check the performances over here. All right, so we use the accuracy. We are checking the accuracy score, right, using the down or under sampling data. Right, so over here you can see that we have 94, right? It has further reduced. We see over here, right, if we use the confusion matrix, right, let's see how the prediction is. Now you can see that in this case it's actually making one wrong predictions for the fraudulent cases, right, and then the wrong predictions for the the not fraud cases has also increased, right? So maybe the upsample technique works better in this case, right? It works better in this case as compared to the downsample. Let's actually use a different technique over here. A different score over here too, and see, which is the F1, and then in this case we're going to use the recall. You can also use the F1 as well, right? So let me actually see. Now you see that the recall is actually better over here too. It's 95, right? But the upsampled, I think the upsample recall was actually making was actually 1, right? You see that that one was 1 for the upsampled. This one is also 95, which is quite good. Right? Which is quite good. So this is good. The upsample and the downsample is actually good. You can see that all the performance metrics are actually pointing to one thing, that our model is doing well. All right, so now let's see another technique called smooth. Right, let's see another technique called smooth. So in smooth, what we do is that we're going to generate a synthetic data. It's more like the upsampling technique. It's just the same concept but different technique. Okay, it's just the same concept but different technique, right? So smooth is just synthetic minority oversampling technique, right? So we see that it's just an oversampling technique, right? It's just oversampling technique, just different way of doing things but the same concept. All right, so let's see how that is actually done, right? So what you can do is that you can install smooth if you don't have it already, right? I have already installed it, so I'm not going to run it, right? Then you can actually do this pip install imbalance lane. But if you have installed it earlier on when we're using the random oversample, right, up here, right, over here, if you have installed it here, you don't need to install it again, right? So that's fine. If you didn't run that one, then over here you can actually install it again. Okay, now what I'm going to do over here is that I'm going to use smooth, right, which is part of the oversampling package in the Imbalance, right? So I'm going to import that, and then over here the normal thing that we do, we define our y, which is going to contain the class, and then our x is going to contain everything apart from the class. Okay, then I just have to split my data using the train test split, which we imported earlier on, right? The same code over here, right, into x train and then the y train, h test and y test, right? The same thing that we did earlier on. Now let's actually go and see let's go and see how the smooth is done. So I just initialize it over here, set a random state equals 27 or any other value that you want, right, just to take care of the randomly associated points, right? And then over here what I'm going to do is that I initialize it to a variable called sm, right, just for smooth. Okay, you can just create any variable name that you want. Okay, now I use sm.fit sample, right, to make it learn from the s train and on the y train. Okay, I'm using s train 1, y train 1, right, over here, because earlier on we did s train and y train. So in order not to override it, I just use s train 1, s test 1, y train 1, y test 1. Okay, so that's basically what I'm doing over here. Then after that is done, what I'm going to do is that I'm going to now perform. So if you do this, right, if you do this one over here, this command over here, this one is going to do that app sampling for you, right? This smooth is going to do that app sampling. So you will not actually need to write this kind of code that we did, this app sampling code that we did all the way up, right? This number of code, this number of lines of code that we did over here, you will not need to do that if you're using the smooth, right? It's going to do the same thing, just that it's an inbuilt function which you can use to actually do that. Okay, so the only thing that you need is this lines of code. Okay, because this part is just the same thing that we've done up there. They are all using the same thing. The only thing which is different is this. All right, then after that what I'm going to use over here is that I'm going to create the same logistic regression over here, perform the predictions as well, then I check the accuracy. Okay, so now let's see the accuracy, 99.2, which is quite good, very good over here. All right, now let's change the performance metrics from accuracy to the coefficient metrics and then see. Right, so we're going to use the coefficient metrics over here. Okay, in this case too, we can see that this one is also less compared to the downsampling, right? If you see the mistakes that the downsampling was doing, right, which was quite huge, right, 333, right, as against, then we have 1 and then 22 over here. So I think the smooth is also doing well, right? The smooth is also doing well over here, right? Smooth is also doing well, 20, right, 20 and then 1, then 41, but not as I mean as good as the app sampling. So far app sampling technique was the one that has done better for us. I mean, this is with regards to this data set. So in a different data set, maybe the downsampling could do better, right, or the smooth could do better than the app sampling. Okay, so you can just keep checking it in that way. You can just keep checking it in that way. Okay, so let's do the same thing on the random forest. Okay, so I'm just going to just import random forest classifier. In fact, we've done this already, so maybe we wouldn't have it won't be necessary to do it again. Okay, so you can just ignore that lines of code. Then over here I'm just doing the same thing. I just initialize my random classifier, and then I'm going to just fit it on it, right? Going to fit on the S train 1 and then the Y train 1 which I've created, and then I made the prediction as well, right? I make the prediction as well and check the accuracy score. Okay, so let's see how it's doing. So in this case, as you can see that we have 98%, right, which is quite good. Now if we change the performance metrics from accuracy to coefficient metrics, let's see how it's doing. Now you can see that it's doing very bad, right? You can see that it's doing very bad. When we change the when we change the algorithm, we can see that the smooth is not actually doing that good. It's not doing that good over here. You can see that it's predicting all the it has ignored all the ones, right, all the fraudulent cases, right? It has ignored all of them. That's why you can see that it's actually predicting all the ones as zeros, right, which is wrong prediction, right? It's not even able to recognize any of them. It has overlooked everything. Okay, so in this case the smooth is not doing well for us in this scenario, right? It's not always the case. It's actually dependent on the data sets and how you even do the hyperparameter tuning. Okay, so in this case we will not go with smooth. We will not go with smooth. We go with app sampling, right? It could vary in different data sets, so you keep on checking different metrics to see how it's doing, and different algorithm as well. In this case, okay, in this case smooth did not perform well when we use the random forest classifier. Okay, so we know good that I think so far the app sampling is the one that did better for us. So if we're supposed to take this model to production, we would have taken the app sample model, right? We would have taken the app sample model to production. Okay, now that you know the techniques that we can actually use in dealing with imbalanced data, I hope now you'll be in a better position when you have a data set that is having imbalanced data points. All right, so keep practicing and see you in the next lesson. Bye bye.